Welcome to dracaenawines podcast. Our wines plus your moments equals great memories. I'm your host, Lori, and this is a podcast about all things wine. Hi, everyone. Thanks for listening in. It's been a while since I did a podcast about the science of wine, so I thought it was a good time as any. There is a lot of debate about who are better tasters, males or females. As a scientist, when there is a debate, I turn to science to find the answer. And quite honestly, I don't understand why there is any controversy. Scientifically, biologically, women are better tasters than men. You can't dispute science. I'm sure you have heard of the 5 S's of wine: see, swirl, sniff, sip, savor. Although most people associate sip as the most influential aspect of wine tasting, it is actually the sniff that is the main sense we use to appreciate wine. We swirl the wine to release the aromas by introducing a small amount of oxygen into the liquid. When we sip the wine and coat our tongue, those marvelous odoriferous molecules are further liberated thanks to our body heat. These aromas are then transferred retronasally to the olfactory receptor site. It is here that we truly experience the flavors. These aromas are known as stereoisomers. These are compounds that take on similar molecular arrangements to familiar scents that our nose and brain can recognize. In other words, you are sensing blackberry, not tasting it in our Cabernet Franc. The olfactory system. The act of smelling involves not only our nose, but many portions of our brain. Smell can influence your emotion, behavior, memory, and thought. In simple terms, once an odor is detected by your sensory organs, nerve signals are sent to the brain where they are processed. Since taste also relies on the perception of molecules, these two senses are closely linked. There's lots of structures that are involved in the olfactory system. First off, the nose. It's the opening containing nasal passages that allow outside air to flow into the nasal cavity. Also a component of the respiratory system. It humidifies, filters, and warms the air outside of the nose. Your nasal cavity is the cavity divided by the nasal septum in the left and right passages. It is lined with mucosa. Your olfactory epithelium is a specialized type of epithelial cell or tissues in nasal cavity that contains olfactory nerve cells and receptor nerve cells. These cells send impulses to the olfactory bulb. The cribriform plate, a porous extension of the ethmoid bone which separates the nasal cavity from the brain. Olfactory nerve fibers extend through holes in the cribriform to reach the olfactory bulbs. Olfactory nerve is the nerve involved in olfaction. The olfactory nerve fibers extend from the mucous membrane through the cribriform plate to the olfactory bulbs. And then your olfactory bulbs are bulb-shaped structures in the forebrain where olfactory nerve ends and the olfactory tract begins. Only 2 more, not too bad. Olfactory tract is a band of nerve fibers that extend from each olfactory bulb to the olfactory cortex of the brain. And then, last but not least, the olfactory cortex, an area of the cerebral cortex that processes information about odors and receives nerve signals from the olfactory bulbs. I know that's a lot of science, a lot of information. If you want to see a picture of it, head over to our webpage, dracaenawines.podbean.com, and you can see the picture of how all of these structures interact and relate to each other. With the ability to recognize over 10,000 different odors, although right now it's kind of being debated, recent research is stating that this is actually a horrendous underestimate. It may sound like our olfactory system is pretty advanced. However, compared to other mammals, our system is actually pretty primitive. Take a dog, for example, whose nose contains 300 million olfactory receptors as compared to about our 6 million. And they dedicate 40% more of their brain to analyzing smells. We definitely lose the contest versus the canines, but within our own species, males versus females, who wins the olfactory evolutionary battle? Well, I already told you that. But here's the science. Before I actually get into the details of the research, I want to start with a disclaimer. Individuals show great diversity in their ability to identify scents and odors, and I am talking about generalizations. Just as men typically are stronger than women, and females normally have better balance than males, yes, there's also science behind those two statements, there are obviously exceptions to the rules. A November 2014 issue of PLOS One studied post-mortem material from 7 men and 11 women, ages 55 to 94 years old. Now, right there, I'm going to say 18 people are not a fantastic study, but it's a start. Although there was no significant difference between the weights of the olfactory bulbs between the males, which was 0.137 grams, and the females, 0.13 grams, there was a significant difference found in the total number of cells. Females have on average 16.2 million, while males only had 9.2 million. That's a 43% difference, and that is significant. Additionally, the number of neurons in females reached 6.9 million, while the greatest number found in the males was 3.5 million, a difference of 49.3%. Again, significance. Generally speaking, says Professor Lent, larger brains with larger numbers of neurons correlate with the functional complexity provided by these brains. Thus, it makes sense to think that the more neurons in the female olfactory bulbs would provide women with higher olfactory sensitivity. So what the heck does all this mean? Okay, odor molecules can enter your system through a primary pathway of your nose or a secondary pathway through your mouth by way of your pharynx. Once the molecules enter the nasal cavity, it then travels to the olfactory mucosa, which is also known as the olfactory epithelium. Again, go back to our home page and look at that picture if you need it, which is actually rather small, about the size of a dime. Within the mucosa, there are olfactory receptor neurons that are responsible for the scent transduction, thanks to the cilia, the little hairs on their ends. Receptors are attached to the neurons. When the odor molecules attach to the olfactory receptors, a series of chemical reactions occur. Think of it as like fireworks. The electrical signal is sent by way of axons of the olfactory neurons to the olfactory bulbs, the brain's smell processing center. From the olfactory bulbs, the signal is sent to the brain where the conscious smell perception occurs. So it's actually a signal, like a spark that your brain is like, whoa, this is whatever. Okay, this is blackberry. This is cherry. So why does all this matter? Since the olfactory bulb is the first synaptic stage after receptor transduction at the olfactory epithelium, it is reasonable to deduct that with women having more cells and neurons, they in turn have an increased odor threshold, discrimination, and identification. There has not been any research, or at least any that I could find, that directly studies the relationship of the total cells and neurons and the ability to be a wine super taster. But I have to admit, it lends itself to a pretty strong hypothesis. Although the reason has not been determined, Linda Bartoshuk, a professor at the University of Florida Center for Smell and Taste, has found that there are more women super tasters than men. In her study, 56% of 4,000 tested Americans, now that's a population, a good study population, So 56% of 4,000 tested Americans were determined to be super tasters. Of the 2,240 super tasters, 34% of them were females, while only 22% of them were males. Why has this occurred evolutionary-wise? Well, there's a few theories on this, but it basically comes down to survival of the fittest. It goes back to the early human existence. Some believe this olfactory ability is essential for reproductive behaviors, such as mate bonding and kin recognition. Having superior smelling abilities was, and still is, a compelling mechanism for sniffing out the right mate. See what I did there? Men may think they are dominant sex, but when it comes to mating, it's all about the female. Female peacocks choose their mate by watching the males go through an elaborate ritual displaying their feathers. The female stickleback fish waits idly by as multiple males spend days carrying small pebbles in their mouths to build a perfect home for her. Yep, ladies, when it comes to mating, we hold the reins, and it seems that it holds true for wine tasting also. So tell me, what are your thoughts on this topic? Do you know men that taste better than women, women that taste better than men? Fill me in. Leave some comments. Let me know what you think. Did you know that dracaenawines now has a wine club? We named it the Chalk Club. Draco is on our label, but Vegas was getting a little jealous, so we decided he deserved to be our club spokesdog. In Las Vegas, betting chalk means that you are betting on all of the favorites. We are betting that we are one of your favorite wineries, so we thought the name was apropos. The club is simple, yet a bit different than most. When you wager on us, we will ship you 3 bottles of wine twice a year, once in April and once in September. You can choose all red or mix of red and rosé. You immediately receive 15% off of all your wine purchases throughout the year, but what makes our club stand out is the progressive discount. Let your club membership ride into the next year. Your discount increases. Each year you parlay your membership, you receive an additional 5% off up to a planned maximum of 25%. Your club shipments are discounted to a flat $15, plus we'll cover your club shipping cost for your second shipment. That's $15 house money in a sure bet for you. So please head to our website, dracaenawines.com, and find out all of the benefits of joining the Chalk Club and how to sign up. We've stacked the odds so that you can get our award-winning wines without breaking the bank. Thanks for listening to dracaenawines podcast. If you have suggestions on what topics you would like us to discuss, please reach out to us on social media. You can find us on Twitter, Instagram, Pinterest, YouTube, Facebook, Snapchat, Google, and Periscope as @dracaenawines. I am also on LinkedIn as Lori Hoyt Budd, or email us at dracaenawines.com. If you enjoyed our podcast, please subscribe and leave us a review on your favorite podcast catcher to help others find us more easily. We are found on all of your favorite aggregators. To subscribe easily to iTunes, go to bit.ly/Dracaena podcast. That's bit.ly/Dracaena podcast. And that's a capital D for Dracaena and capital P for podcast. Please check out our award-winning wines and find out about our wine club at dracaenawines.com. And remember to always pursue your passion. Sláinte!